assess and mitigate the vulnerabilities of security architectures, designs, and solution elements. Welcome to this module on assessing and mitigating vulnerabilities in security architectures, designs, and solution elements. Every information system has security risks that must be identified and mitigated before they can be exploited. Whether it's a client-based system, cloud environment, or Internet of Things IoT device, vulnerabilities exist in different architectures. In this lesson, we will discuss how to assess security risks and apply mitigation strategies across various system architectures. Let's get started. Security architecture vulnerabilities are weaknesses in system design, configuration, or implementation that can be exploited by attackers. Organizations must assess security vulnerabilities for these major reasons. Prevent cyber attacks, identify weaknesses before attackers can exploit them. Ensure system resilience, improve security by reducing design flaws. Maintain compliance. Security assessments help organizations meet regulatory requirements like GDPR, HIPAA, and PCI DSS. Now, let's look at an example. A company deploys an insecure API in their web application. A hacker exploits this weakness to gain access to customer data. If the company had conducted a vulnerability assessment, they could have detected and patched the API flaw before the breach occurred. Here's how to effectively assess and mitigate security vulnerabilities. Conduct regular vulnerability scans and penetration testing. Use secure coding practices to minimize architectural flaws. Apply patch management to fix known vulnerabilities. Different system architectures have unique security risks. Let's explore vulnerabilities in various system types and how to mitigate them. Client-based systems. Client-based systems rely on user devices like laptops and mobile phones to access applications and data. Common vulnerabilities, malware infections, weak authentication, and unpatched software. Mitigation strategies. Use endpoint protection, enforce multi-factor authentication, MFA, and implement regular security updates. Server-based systems. Server-based systems host applications and data in centralized environments. Common vulnerabilities, weak passwords, misconfigured access controls, and outdated software. Mitigation strategies enforce strong password policies, implement least privilege access, and use intrusion detection systems, IDS. Database systems. Databases store and manage sensitive information, making them prime targets for attackers. Common vulnerabilities, SQL injection, weak encryption, and excessive user permissions. Mitigation strategies, use prepared statements to prevent SQL injection, encrypt stored data, and enforce role-based access control, RBAC. Cloud-based systems, Cloud environments provide flexibility but introduce new security challenges. Common vulnerabilities, misconfigured storage, insecure APIs, and lack of encryption. Mitigation strategies. Implement cloud access security brokers, CISSP, use encryption for data at rest and in transit, and apply zero trust principles. Internet of Things IoT devices. IoT devices, such as smart home assistants and industrial sensors, have limited security features. Common vulnerabilities, default credentials, unpatched firmware, and lack of network segmentation. Mitigation strategies, change default passwords, apply firmware updates, and use network segmentation to isolate IoT devices. Here's an example. A manufacturing company uses IoT sensors to monitor machinery. However, the sensors use default credentials, making them vulnerable to hacking. By enforcing strong authentication and firmware updates, the company can mitigate this risk. Here's how to mitigate security vulnerabilities across different system types. Secure client-based systems with endpoint protection and strong authentication. Protect server-based systems with intrusion detection and regular patching. Secure databases with encryption and access control measures. Enforce cloud security policies using encryption and zero trust models. Harden IoT devices by disabling default credentials and enabling firmware updates. Emerging technologies such as containerization, microservices, and serverless computing introduce new security challenges. Microservices and APIs, misconfigured API endpoints can expose sensitive data. Containerized applications, e.g. Docker, Kubernetes, unsecured container images may introduce vulnerabilities. Serverless computing, lack of visibility into execution environments can lead to data leaks. Here's an example. A financial services company deploys a containerized application without scanning images for vulnerabilities. Attackers exploit a misconfigured container to gain access to sensitive financial data. By implementing container security scanning and proper access controls, the company can prevent such attacks. Here's how to secure emerging technologies. Use API gateways and strong authentication for microservices. Scan container images for vulnerabilities before deployment. Implement serverless security monitoring to detect unauthorized access. Regular security assessments help identify and fix vulnerabilities before they can be exploited. Vulnerability scanning uses automated tools to detect weaknesses in systems. Penetration testing, pen testing, simulates real-world attacks to evaluate system security. Here's an example. A retail company conducts a penetration test on its e-commerce website. Testers find that the site is vulnerable to cross-site scripting (XSS) attacks. By fixing the vulnerability before attackers exploit it, the company strengthens its security posture. Here's how to conduct effective security assessments. Perform regular vulnerability scans to identify security flaws. Conduct penetration tests to simulate real-world cyber attacks. Remediate identified vulnerabilities immediately to prevent exploits. Now, let's summarize what we've learned about assessing and mitigating vulnerabilities in security architectures. Security vulnerabilities exist in various system architectures, including client-based, server-based, cloud, and IoT environments. Each system type has unique risks requiring specific mitigation strategies. Emerging technologies such as microservices, containers, and serverless computing introduce new security challenges. Vulnerability assessments and penetration testing help organizations detect and mitigate security weaknesses. By proactively assessing security vulnerabilities and applying mitigation strategies, organizations can reduce their risk exposure and strengthen their defenses. This concludes our module on assessing and mitigating vulnerabilities in security architectures. Up next, selecting cryptographic solutions. Stay secure.